Exercise number 5 in the Annabac. This is a very good guide in order to use it to solve extra exercise. So we'll do exercise number 5. So here the question is a chariot of mass m equal 100 gram is pulled on an inclined plane by a rope enrolled on the periphery of a pulley and carrying at its other extremity a small mass as shown in the figure A. We neglect frictional force. So هيدي we neglect frictional force. This means we should know that the mechanical energy is conserved. So here عرفنا شو ما نستعمل if we will use it. Okay, and we give that G is equals to 10 and you have the angle alpha. Represent on the figure the forces acting on the chariot. So as forces here, now we can represent it here as simulated to a particle and represent the forces. So we have the weight, we have the normal force, we have the tension, and قالنا there's no friction, so that's it. هيك نكون قسمنا الforces. Now applying Newton's second law, calculate the tension in the rope as function of mg alpha and dp over dt. So بنلاحظ هون قالنا in terms of dp over dt. So this is why when I want to apply now Newton's second law, I will say here in the part 2 that according to Newton's second law, أكيد the system هو chariot, so I will name it C. The system is C. And according to Newton's second law, the summation of F external is equal to dp over dt. ليه ما حطيت MA؟ لأنه هو بده in terms of dp over dt. So this is over dp over dt. وما بننسى steps. So the steps are we present the forces. هي هون we have the axis. This is the x-axis. And then we put the forces. So we have the weight plus the normal plus the tension is equals to dp over dt. This is in terms of vector. Now, in terms of value, so بنعمل projection over x. So projection over x. And here we'll have, so W is بنلاحظ it's opposite to the x-axis. So its projection هيها, this is Wx, which is negative. This is Wx. So it will be here minus mg sine alpha. And the normal, its projection is 0 since it's perpendicular, and the tension, its projection, it's plus t since it's parallel and same direction to the x-axis. So هيطلع عنا equal to dp over dt. And the question was to find t in terms of, so this means that t is equals to dp over dt and plus mg sine alpha. Plus mg sine alpha. هيك بنكون جاوبنا على السؤال. Now this one أكيد ما نخليها معنا لأنه maybe you will use it in the other parts. So بنكمل 3. Given the variation of the linear momentum of the chariot as function of the time in the graph, what are graphically the speed of the chariot at t equal to 0? It's very, very important at all when I have a graph to pay attention to the variables. So here it's p in terms of t. This is the y. Okay, and this is the x. So هيدا كتير مهم ننتبه له. So and the question is the speed. So we know that we don't have speed here in the graph. What do we have? We have p. And we know that p is equals to m times v. So this means كأنه عم قلنا find, determine graphically the linear momentum at t equals to 0 and then deduce the speed. So هون we can say in the part A that p0 is equals to m times v0. And using the graph, if we look here, P0 is approximately 1.2. So here, it's approximately 1.2 kilogram meter per second. So here صافية لكن صافية نحط ال value. This is approximately 1.2 here. So صافية نحط الأرقام and we have كان نحنا معنا the mass is equals to as given, so كانت 0.1 kilogram. So صافية حط it's equals to 0.1 kilogram times V0 اللي هي 1.2 and هيك بيطلع لنا P0, sorry, this is P0 is equals to 1.2 equal to 0.1 times V0 and هيك صافية نطلع V0, so V0 it's equals to 12 meter per second. This is هيدا بالنسبة لأول part A. Now in the second part A, first point. Now in the second part, I want to find the instant of departure of that chariot. When I say the instant of departure of the chariot, يعني the time where the chariot starts moving, this means when I say starts moving, so this is the question, with the time where the speed was equals to 0 and increases. So I want to find the time where P was equals to 0. لأنه كأنه عم بقول V is equals to 0. إذا بنلاحظ هون I don't have P equals to 0. So what should I do? I should prolongate. And when I prolongate, then I obtain here an answer, which is approximately minus 0.6. So here in this part, the instant of departure, so the instant of departure will be t equal to minus 0.6 second. Now, إذا بتلاحظوا, it's negative. This doesn't mean that I have a negative value of that of the time, but this means that it begins its motion 0.6 before representing this vector, this graph. Now in the part B, deduce using the graph the value of t. So نحن كان طلعت معنا t is equals to dp over dt plus mg sine alpha. mg sine alpha. But we already know that when I say dp over dt is the slope of the tangent to the curve, or the slope of the line if it was a line. So I can say that dp over dt is approximately equal to delta p over delta t. Okay, so which is here, for example, I can take any 2 points. So for example, this point and this point, or others. So it will be P final minus P initial over T final minus T initial, and I took these 2 points. So حيطلع عنا as answer, it's 1.2 minus 0 over, it's a 0 minus between bracket minus 0.6. And so the answer will become equals to 2. بعد ما طلعنا delta P over delta T, so we can substitute. So we'll have here it's 2 plus the mass, it's equal to 0.1 kilogram times 10 and times sine 30. Okay, so here we'll have sine 30, it's half, so 0.5 and 2, so the answer will become it's 2.5, so it's 2.5 Newton. This will be the tension of the string.